follow the rotation. Okay, like what we have written, will follow the rotation of the object. Okay, rotation will follow the rotation of the object. Okay, you'll follow. So we have our moment. Remember, we had our moment earlier. So I'm going to impose the moment. So we have a moment over here. Right. So if that's our moment, we also know where that you. I mean, so the angle theta is going to rotate from the z-axis. I repeat again, theta will rotate from the z-axis, and clockwise is positive. Okay. This has nothing to do with right hand rule. Okay. How we draw it, because we have this orientation, we declare that clockwise is positive. So we know, we also are aware that this will break down, right, the moments into two components. So this is your mz, and then another one. This is your my. Okay. Right. And then we have a relationship that we can form later on. Okay, so I'll come back to this diagram later that we have just drawn. So from here, if we look at equation 2, all right, we look at equation 2, we can, if we were to rearrange them, you can have y over z. Okay, y over z is equal to my divided by mz. Right, so my over mz, izz over iyy. Okay, we have this expression. And this expression is, I'm going to call this expression as our equation number 3, right? So we're going to let tangent theta, right? Like what we have over here, we're going to let tangent theta is equal to my over mz. And again, I'll elaborate down here, positive is going in a what? Clockwise direction, right? So we know this relationship from the figure. So we're going to substitute tangent theta into equation 3. And then from here, we know that y over z is equal to tangent theta multiplied by izz over iyy. Okay. So this is our equation number 4. Now, coming back to this figure again, okay, coming back to this figure again, I'm going to sketch a line. So this line, I'm trying to pick the right color. So I'm going to go for blue now. Okay, we're going to sketch a line. Okay, so this line has this orientation. I hope this is not pink. Okay, sorry, sorry everyone. I'm partial colorblind. Okay, that's why I cannot do chemistry. Right. So what I've just drawn, this is known as our neutral axis. And the neutral axis, the frame of reference again is from Z. And this I'm going to call pi. Okay. Again, I will elaborate. Pi is the orientation of the neutral axis from the z-axis. So i.e. clockwise is again what? Positive. We are so used to anti-clockwise positive, isn't it? Right? So over here, if we pick a point over here, right? We pick a point over here, we know that the point there will have gradient or will have position, and the position it will have, so this position it will have, so this is your y, right? So this is your y, and this position from here to here, this is your what? This is your z. Okay, so we can form another relationship with this diagram over here, where tangent pi right, tangent pi is equal to y over z. Okay, and again I elaborate that positive is going in the clockwise direction, right? So we're going to substitute. Okay, we're going to substitute. I'm going to carry on writing. So we're going to substitute tangent pi into equation 4. So what we have now is tangent pi is equal to tangent theta, right? Izz over Iyy. Okay, and pi, what we see over here, so this is the final form. What we see over here is that pi is the what? Is the angular orientation of the neutral axis relative to the object axis. Okay, relative to, so object over here, so I'll call this is our object. Okay, did we call it object earlier? Yeah, object axis. Okay, now let's do one very quick example. Okay, I will be done in not more than 5 to 10 minutes. Okay, I know you guys are exhausted listening to my voice. I get tired listening to my voice. Now, let's look at another example. Okay, don't worry, it's not that bad. I know it looks really shitty. It has a lot of stuff, but don't worry, it's straightforward. Okay, right. So now, this is the question that we have. So for this case, we want to find, so this is example number 2. So I want to find, so the first thing, I mean, yeah, I'll do first part, I will continue again. So we're going to do example number 2 is we're going to find the orientation of the neutral axis. I do apologize. I went for the before I go on viewing from here. Anyone has any question? I do apologize. Okay, I should have asked. Anyone has any questions based on what you see? Anyone, please.
Eugene, the only my one question is, you know the theta and the phi.
Yep.
Why wouldn't it just be theta orientation for the neutral axis? Why is it?
Because the how the moment is acting is not necessarily parallel to the neutral axis. Right? You're talking about these two angles, yes or no?
Yeah.
Right? So these two angles over here, right? So what I just said is the moment axis, right? The moment axis is not necessarily equal to the neutral axis. Does that make sense?
Makes
So
sense.
yeah, this moment over here is not necessarily acting parallel or on the same orientation as your neutral axis. Good question, by the way. I never thought about that. Okay.
So my own like the thing is what I'm trying to say is like is the moment causing the neutral axis to shift or is it
Yes, it's
okay?
causing is the moment is causing it to shift, and it's also based on the second moment of area of the object.
Okay.
Okay, so that's how it is moving. Right.
So sorry, another thing.
Yep.
So
Yep.
would there be a situation where both the same?
Possible. Yes.
Okay, makes sense. All right.
Okay. There's a
Thank
possibility. Yes, and
you.
it can only happen if it's a circle.
Okay, makes sense.
Okay, and maybe some intricate shapes. Okay, it can happen like eight-sided pentagon. Yeah, or eight-sided octagon. There's a possibility also.
All right,
Okay,
thank you. Makes
right.
sense.
Right, so we're going to find the orientation of the neutral axis. Okay, so we know what we see now is we know that we have a IY prime, right? IY prime is equal to 6.74 inches to power 4, and IZ prime is equal to 21.4 inches to 4. Now, you can see that the Y prime and Z prime is taken such that it's somehow parallel or perpendicular to the structure, yes or no? Right? So somehow, like this geometry over here is parallel to your Y prime. This geometry over here is parallel to your Z prime. Okay, y'all can observe that, right? Now, that is why I say that the transformation or the axis is relative to the what? To the object. Okay, the axis is relative to the object. If it is relative to planet Earth, so let's say, okay, I want to be stubborn. I'm not saying that you can't. You can. I want to take my transformation axis that this is going to be my y, and then this is equal to my what? This is equal to my z-axis. When you do that, what is the consequences? Anyone?
Your second moments of areas are going to be a mess.
Yeah, well done. Your name?
Jacob.
Jacob, well done. Okay, when you do that, it's not impossible. Mathematically, you guys have done 2ZZ03 or 2ZZ06, whatever. Your math is better than mine, I'll tell you that. Okay, but I'm going to get bloody headache on trying to find the second moment of area over here. Okay, so that is why when we prove the previous concept, what did I always mention? right? The axis always rotate with the object, okay? And it somehow is always somehow we are able to see that it's parallel to a certain aspect of your what geometry, right? Like this is parallel, the axis